Welcome to week 3. This week we're going to talk about numerical computing with NumPy. So NumPy is a tremendously valuable resource library for you that you can use inside of Python in order to do a lot of things related to manipulation of actually doing calculations off of numbers, things like standard deviation, arrays, sorting arrays, etc. Those are all like valuable things that you can do with NumPy. For this week's reading, ask that you read Chapter 4 in Python for Data Analysis. And we're going to focus on all 5 of the learning objectives for this week. What I'm going to do is I'm going to kind of show you an example, run you through as an example script, and just to mix it up a little bit, I'm going to go ahead and use Jupyter Labs. So again, as we talked in the initial videos, you can use any one of the editors that you choose. I'm going to show you kind of a mix of all of them, of the 3 main ones that I've talked about. So within Jupyter Labs, if I launch Anaconda, I can just launch Jupyter Labs directly. And that pulls you up to something that looks like this. Now, again, if you're using this in a cloud environment, you're using this in AWS Azure or a container environment, this will be very familiar. This is a very common way that you would see your Jupyter notebook presented to you. So let's say I wanted to upload the scripts for this one. I'm going to go ahead and choose Upload. And I know that I have it downloaded to this directory. I actually have both the student sample one as well as the demonstration script. Let me load the demonstration script first. I'll go ahead and snag the student one too as well. And then simply double clicking on it, that gets me to a Python instance over here. So very similar to what we've seen before, as far as there's markdown sections and then there's a code section down here. For this week, the objective is to introduce you to numerical computing using the NumPy library and understanding NumPy arrays and basic NumPy operations. So the text goes into quite a bit of detail of how you can do various pieces of this. I'm going to go ahead and just give you 5 examples here. So first, and this last one is for the mean. I didn't put the word on there. Sorry about that. So first of all, we're going to create a 1D NumPy array with integers to 1 to 100. Next, we're going to create a 2D NumPy array with the shape of 4 and 4, filled with consecutive even numbers starting from 2. Third, we're going to create a 3 by 3 identity matrix using NumPy. And then fourth, we're going to do the dot product of those 2 given numbers. And the last one, we're going to do the mean and the standard deviation given the NumPy array. So to start off again, I'm going to have to import NumPy. So NumPy as NP, and NP is the common way that you would represent that. So I would stick to standard things, such as with pandas, it'll be PD, etc. So with NumPy, import that as NP. That's going to give us the library. And then in order to do that array, to create that array, and just do it for a numbers from 1 to 100, you can simply use the arrange keyword. So right here, I just say, I'm going to assign a new variable, call it array, and then NumPy array, arrange 1 to 101, and then print the array. And here you can see, it's created a 1D array, a simple array with integers from 1 to 100. So now the second question, to create a 2D NumPy array with a shape 4 of 4. So again, we're looking for 4 columns, 4 rows. That's the 4 of 4 right here, filled with consecutive even numbers starting from 2. So the first, and you can see this is an example of how you can chain commands together. So it's very similar to what we did in the first one. We're going to do the NP arrange, and I'm going to give it skip by 2s, 2 to 34. So I'm going to start on number 2, I'm going to go out 34 with that, and I'm going to jump by 2s. And then after I get my array, which would originally come out looking like this, I'm going to, with again obviously skipping by even numbers. Then I'm going to turn around and do a reshape. Reshape is going to take that and move it into a 4-column, 4-row function. And so that's what you're kind of seeing right here. So let's say I wanted to create an identity matrix. Again, there's a really handy keyword, identity. So I'll continue to import NumPy as NP. I'll have the identity matrix equals to NP identity. And since I'm doing a 3 by 3 array, I simply use the number 3 and it automatically generates that for me. Then I simply do the print. So this is very, very handy when you have to do covariance matrix as things along those lines. You can generate those simply by using one keyword. So that's why it's kind of important to you to kind of learn that one. The next one is to find the dot product of two given NumPy arrays. So again, this demonstrates some of the simplicity of Python as a language. Let's say I have an array. I'm going to have an array here of 1, 2 jumping by 3s, and I'm going to have the NumPy array of 4, 5 jumping by 6. And just by using the dot operator right here, it'll do the dot product. So if I did that, run that out, 32, and that's how you do a dot product. So adding arrays, subtracting arrays, multiplying arrays, very simple to do that using simple keyword operators. Instead of having to manually kind of spin through using a for loop, for example, each element of that array. So this is something that's this kind of stands head and shoulders above several other type of languages because you can kind of do this all within one command like this. And then finally, I want to calculate the mean and the standard deviation. This is a very common statistics type function. So let's say I had this as the array right here, simply using the mean keyword. So using np dot operator mean, and then feed it the array as the parameter, and standard deviation using std. And then it gives us the printout here, as you can see. So again, some very simple type examples, but this is showing you some of the major things that you can do with an array and how you can use NumPy in order to do that. So again, we're starting with some of the basic building blocks. This is the elements that you could use for doing that. Now let's go on to the example that you will do. So for yours, again, you'll start off with your sample, your example notebook here, which is provided for you. Remember again to put your name up here, and then it's specifically listed out. So in this one here, we're going to look at numerical computing using NumPy, manipulating NumPy arrays, and performing mathematical operations using built-in functions, and apply that to transform the data. So your 5 questions that you're going to have to answer: create a 1D NumPy of size 10 filled with zeros. Second question, and so that was very similar to the first question that we had over here. Second question, create a 2D array with shape 3, 4 filled with random values. Very similar to this one right here. Create a 3D NumPy array with shape 2, 3, 4 filled with ones. Very similar to what we did. Add 2 NumPy array elements, arrays element-wise. Very similar to what you did here in the fourth question, the dot product. And then multiply 2 NumPy arrays element-wise. The grading, the deliverable is, of course, this notebook. You will turn this notebook in and make sure that you submit that response in Blackboard. I'd also ask you to check it up into your GitLab, GitHub, your Git repository. Grading criteria, you'll be graded on the same criteria of correctness of implementation, proper use of basic control structures, code efficiency, and this is a key one on this one because several ways that you could solve the problem. You could manually populate an array. That's not the most efficient way to do it. So when I say code efficiency, it means to do it similar to what you saw in your example here. Adding 2 NumPy arrays element-wise and the multiply pieces of it, those again fall into that same kind of a category. So don't want to just manually assign the array. You want to actually do the keyword using the action keyword on it. So Clarity and readability of the code should not be an issue for this assignment. And compliance with the instructions and the deliverables. Make sure you double check everything to make sure that you've answered all of the questions. So that's the assignment for this week. If you have any questions, please reach out on the forums or come to the office hours and we can field the questions there or respond in email. Have a good one. Thank you.